Chapter 11, number 48. A torque of 0.12 Newton meters is applied to an egg beater. A. If the egg beater starts at rest, what is its angular momentum after 0.65 seconds? And B. If the moment of inertia of the egg beater is 2.5 times 10 to the minus 3 kilograms per meter square, what is its angular speed after 0.65 seconds? So, an egg beater is, as far as we're concerned, some sort of object that can be rotated, and we apply a force that creates a torque that creates an angular acceleration. And we basically come back to using the angular version of the impulse momentum theorem, that the impulse is the torque times the time during which it applies. And that's also the change in angular momentum. So for us, the angular momentum starts off at 0 and ends at the thing we're looking for. So we can turn all of that to saying that the thing we want is just going to be the torque times the time. 0.192 Newton meters times 0.65 seconds, or 0.078 Newton meter seconds. Kind of a strange unit actually for angular momentum, but I guess that's fine. And then that was part A. And part B, well, we can also say that the angular momentum is I times the angular speed. So the angular speed is that momentum over I, or 0.078 Newton meter seconds, all over 2.5 times 10 to the minus 3 kilogram meter square, or 31.2 radians per second, which clearly becomes just 31 radians per second because of sig figs. We have only 2 of them.